Hi, everyone. Welcome. Thank you for joining us today for our session on multi-database subsetting. My name is Kiara. I'm on the marketing and developer relations team here at Tonic, and I'm excited to introduce you to our speaker, Johnny Goodnow. Johnny is a staff software engineer here at Tonic, and he's been largely responsible for the development of our subsetter. So he has a fantastic presentation planned for you, and we're excited to get into that. We'll also leave plenty of time for questions at the end of Johnny's presentation, so feel free to drop those in the Q&A, and I will cover them at the end. With that said, I will hop off now and pass the mic over to Johnny. Thanks.
Awesome. Thanks, Kiara. Hello, I'm Johnny. I'm an engineer at Tonic, and the goal today is for me to talk about subsetting. And so really what this is it's shrinking your database down in size and a lot of the utility that comes from that. So we're going to talk a little bit about, how it's useful, how to do it in a performant manner, and kind of Tonic's unique approach to handling this problem. So we're going to split this into a couple segments. First, we're going to talk about, what is subsetting? Why does everyone need it? Why is it useful in all kinds of domains? We're going to talk about, in addition, the challenges of subsetting, why this isn't just an easy tool to find off the shelf, including when we originally started developing it. And then, of course, Tonic's unique approach to subsetting and some of the things that we've learned along the way. So let's start off with, what is subsetting, right? So subsetting, very simply, is it's intelligently shrinking your data, right? Or to have like a stronger definition here, to take a representative sample of your data. And you want to do this in a way that preserves the integrity of the database. You want it where related data still maintains those relationships, especially if you're typically using a more relational style database, SQL, etc. And being able to ask yourself like a question of, give me 5% of my users, and not just 5% of users from the users table, but all of the things that are related to those users. So that way you can have the full story, but at a much smaller scale compared to a production data set. And so here we have like a really basic, schema. We have, this could be for like an e-commerce company. If we have products, purchases relate to products. Products can have reviews for them, and then there could also be favorites that are tied into, specific reviews or products, etc. And so, at a very simple level, we decide, okay, the core of our database is products in this particular case, and so we want to grab some data from the products table. And then we want to also grab, related data from these other tables, right? Based off of that initial, that core of the database, right? In this case, let's say, 10% of the products that my company sells, and I want all of the other things related to it. And this includes both having data that is necessary as well as data that is optional, as far as how like databases are typically designed. And so why is this thing useful, right? Well, first off, production data tends to grow in size and complexity over time, right? It's just one of those things that, it won't be long before it's far outside of the realm of just one person's head. Likewise, testing and analyzing that data can be a bit of a mess, right? You can run into problems with security. You can run into problems with like causing downtime for other users who are utilizing this data. You can have access concerns. You can also have regulatory requirements, especially if your industry has very specifics around who can access, production data, particularly if it has information about individual users. And making sure you respect their privacy. And finally, sometimes modifying that data is very risky and sometimes impossible, just because of many of the other concerns already mentioned, but also just because you can't necessarily disrupt people who are utilizing the core production data set. And a common solution that you might think right off the bat is, well, what if we just make a full copy of this thing and we throw some masking on top of it? It actually turns out it takes a lot of money and time to continuously do this, and especially if you're refreshing this data often, or if you end up having it where different teams end up having their own copies and they need specific details about that data. It just becomes very expensive and very time consuming, especially if your data set is already really large. Likewise, it's a lot, continuing down the road of being cheaper. It's also just cheaper to store data if you're storing it in the cloud or even on your own hardware. It's less bandwidth necessary to retrieve and share that data with others. And it's less time spent just packaging and building that data for different environments, especially if you want to have different complete versions of your data set for a test environment versus a staging environment versus an analytics environment. It simply can cost a lot of time just to be able to package all these things, to have automation around building these different data sets based off of your original production data set. And then finally, it's just a lot easier to use a smaller data set, right? It's more easy to share it. You could load it up on your own laptop and not need to utilize servers. You can have it where different teams and services can have different subsets of data, right? And this becomes really important when you're thinking about things like microservice architectures or teams that only really care about like a certain slice of data and only certain tables or objects within the schema. And finally, it's also easier to tune it such that you can kind of curate a more specific data environment for reproducing issues, testing, analysis, etc. And many different contributors on the team are going to be able to utilize this, right? Like developers can more easily build and test bugs and features with a smaller data set. QA can more easily reproduce bugs with specific conditions. Data science can know that they're working with a representative data set and still be able to have faster queries, or just be able to kind of do some spitball analysis a little easier. And it's simply better for the majority of teams in general to have something that, is just going to be a lot less unwieldy compared to a large production data set. And so, we talked a little bit about, kind of what it is, why do we need it, and wanted to go a little bit into the challenges of subsetting, right? Like, why isn't this something that, you can do easily? Well, first off, it's hard. Right, to simply take 5% of a single, table, let's say a user's table, it's much harder to get all of the related data. And even if you get all of the related data from a referential integrity standpoint, you're making sure that if if you have related data, that all the necessary relationships are being made. That doesn't necessarily mean that the subset is going to be useful. And this is because much of the valuable data is optional from a referential integrity standpoint. And we'll get into some specific examples showing how optional data really comes into play. And likewise, what a good subset is can be hard to define. Different organizations and domains have very different needs, including what data is included, what data systems they're using to store that data, and ultimately how they're related. Sometimes that can be represented in the data system itself, such as foreign keys for a SQL database. Other times that can be just in the app logic itself, where individuals at an organization have decided how they're going to link related data, especially across different data systems. And most organizations usually just try taking a simple cut. And if you don't actually try to make it useful, people just don't use it. And they would rather, move back towards production, or just feel a lot of frustration and just decrease productivity, really trying to utilize data that doesn't have high quality to it. So if we look back at our original example, we have for our reviews, favorites, purchases, etc. The thing is, these tables could often be in many different kind of domains, right? There could be other related tables. It's never just 4 tables, right? You know, it could be on the order of hundreds of tables. And on top of that, they could be stored in different databases, right? But they could still have identifiers that link between them, right? And it's not just ever, you know, 3 databases. It could be many databases, right? It really depends on the scale that you're looking at and how your organization is continuing. Well, really leading to this complication of how do we actually, you know, traverse all of these relationships and make sure that we grab all of the data necessary to build this statistically representative subset. Now we can also take a look now at take a look at more of a micro level for this particular problem. Much of the issue with dealing with multiple databases is often just how do we query that data? You know, you just tell us which servers to point at, and we'll grab that data as long as the identifiers actually mix and match across different systems. But there are also other problems that exist within just a set of tables. So for example, let's say we grab some data down in this particular table in the middle, and we start looking at some of its neighbors. Okay, let's start grabbing related data to it, right? We grab some table next to it, okay, and then we grab some more data at another table that relates to that one. And if you look at the arrows in the center, you may already notice that what we actually have is like a cycle, right? And so and cycles are very common in data schemas that are out in the wild. And inherently the problem becomes how much data should I continue to collect? If I start at a certain point, and if you don't actually work with that cycle, you could end up just copying the full table for all 3 of these tables. And often the cycle is much larger than 3 tables. It can be across 30 tables where the cycle exists. And in that case, you don't actually end up with a subset. You just end up with a copy of the original data, and we haven't solved anything. And so all of these problems really come into play when trying to even build an algorithm to intelligently do this, to take in mind different systems. And a lot of that is kind of at the core of what Tonic really does. So I want to talk a little bit about Tonic's approach to subsetting. Also just wanted to check if anyone had any questions up to this point. Otherwise, I will keep going. Let's take a look. Okay, cool. So I will continue going. So the way that Tonic handles, all of these problems is, comes across in like a variety of different contexts. So the first thing we do is we try to keep the configuration simple. So we have it where a user specifies, a specific target. That could be a users table or a products table, something that they feel is the core of their database where most of the relationships end up tying to. And then some condition, right? Say 5% of the users, but they're also all in the state of California. One thing that we noticed early on is that a lot of the few open source tools that existed for this were often very difficult to configure in order to get a subset that you actually wanted to use. And we wanted to really abstract away a lot of the challenges that exist in producing a good subset. From there, we iteratively explore all the connective objects, and we make sure to grab optional data where it's useful, and then necessary data to ensure referential integrity. And we likewise, we handle a lot of complex data schemas, including ones that have referential cycles, but also more complicated relationships between composite keys, handling cases where tables or objects could have multiple different unique identifiers to them, which different tables will point to, and many others that we've come across along the way working with many of our customers. And so notably, the algorithm works at a very high level that we sort the tables according to their dependencies. And this is done doing a topological sort, which is often used for ensuring that, tasks, for example, are done in a dependency order. You never work on something before all the things you had to get done before it have been finished already. And so we likewise do this for the tables and their relationships themselves. We then subset the target table or object. We can talk a little bit about NoSQL at the end. And then we add optional data, which we consider upstream of the target. And we'll show some pictures explaining that. And then finally, we make a downstream pass, which takes all the required data that is necessary in order to have referential integrity. And so here's, kind of keeping in our theme of e-commerce, we have what now is a topological sort. You have all of the dependency arrows are now going from left to right. And we've decided at this point that, okay, SKUs are going to be the core of the database. This is going to be our direct target. And let's say we decide to take, 10% of them or something like that. From there, what we want to do is we want to go upstream, right? And so what this means is we're going to grab auxiliary information, optional data on a specific row. So looking back at our picture, right, we have products in the center. Reviews points to products, which means that a review can exist for a product, but a product doesn't necessarily need to have any reviews. Makes sense, in the context of reviews for an e-commerce product, right? And it's auxiliary because it's not required. Technically, a valid subset would be that we could just grab no reviews for any product in the database, and that would still work, right? You wouldn't have any complaint at the end that any foreign keys are violated or any app logic downstream. But it's not necessarily as useful. You probably, maybe you're interested in reviews. Maybe you want to do analysis on those reviews based on those products and, what categories those products are in. So we find it essential to actually go through and pull optional data off of them. And we do this by following the relationships between these objects. So for every product, we grab the reviews associated with it. But we also have options to filter this data. So because it's optional, we could say, hey, only grab reviews that have been published in the last 30 days. So that way we're not grabbing reviews from all time. And there's a variety of ways to do this, either by grouping or by just having conditions like this where we look at the published date of the review. And this process generally continues upstream, right? So we look at products. Purchases is also directly upstream of SKUs, so we grab some data from that. And this continues all the way up until we basically reach what I like to call the top of the table graph, right? And so these are going to be tables that have nothing that reference them and are safe to essentially start the downstream pass, right? Where it's okay if these tables have no data in them, but when we go from left to right, we have to make sure every subsequent table has data in it. And so this is the downstream aspect of it. So what we do is we want to gather necessary information to support a row. So looking back at this, products must have an SKU associated with it, right? And this is kind of the arrow pointing from left to right from products to SKUs. Without an SKU, you would have it where, particularly if this relationship had a not null constraint, it wouldn't actually be valid, right? You need to make sure that SKUs are imported for every product that you import. And so this is one of the reasons why we go upstream first to grab any optional data, but then we go downstream after that to make sure that we basically fill in the gaps, to make sure that all data grabbed previously, that references something that isn't already in the database, we want to go ahead and grab along the way. And once all these requirements have actually been met, the subset is complete. And this is referential integrity. So we start over and, over at like favorites and this other unnamed table. And you can see when we go to reviews, you have it in like a different color. And so what this could mean is that at some point, we may have grabbed rows in the favorites table, but are not present in, weren't already in the reviews table, right? And this is all in the perspective of the destination, the subset that we're creating. So what we do is we check the source. Oh, were there reviews that were not already imported? Let's go ahead and import them now in order to ensure that we're actually maintaining this referential integrity. And this like completes downward. And so you could have some cases where, for example, the purchases table may have all of its records, are already present in the table, and you don't need to grab additional data to maintain these referential checks. But the products table, in this case, actually, we didn't have all the data, so we grab a little bit more data from the source to fill up those gaps. And we continue this down all the way to the targets, but actually all the way through the rest of the connected tables in the database. And this is to ensure that, again, at every single relationship, we go ahead and manage data that needs to be imported, and no foreign key dependencies are broken at the end. And so some of our differentiators to making this work is that we're able to create a single subset from multiple different data stores. You could again have your database be highly sharded. You could have it on different hosts, like etc. As long as the identifiers are generally assignable between each other, we can go ahead and subset off of those. We also allow users to have multiple targets in their database, right? It doesn't necessarily just have to be SKUs or products. It could be, we could have 10% of SKUs, and we also want to make sure that we want reviews from the United States, just because both of these use cases are useful for us. And it handles the logic in order to, again, both grab optional data upstream and necessary data to fill everything out downstream. And we also provide a bunch of other advanced features, including reference tables. We have the ability to filter data, so that way you can control how large the subset ultimately ends up being. And we also have the ability to add additional data relationships. Not everyone has their relationships as foreign keys in the database. And so and also you could have it where two tables have it where the relationship between them is in app logic. And so we have the ability to let Tonic know that a relationship exists between two tables and how to go ahead and figure it out that way. So, and ultimately, I think probably the biggest thing that Tonic provides is that our entire privacy preserving feature set is available to the subset. So that means that, not only do you have the benefits of shrinking this thing down, but you also have all the benefits of removing any private information that exists. So you can mask identifiers, you can mask email addresses, names, etc. All while having a smaller subset. It's very useful for creating a good test and staging environment where you don't want users to be able to know what records they referenced in the original production data set for user privacy, purchase privacy, etc. Yeah. And just to give like a specific example of this, we actually do a lot of subsetting over at our customer eBay. Notably, eBay has 8 petabytes of data just across a vast number of data sources. And it's really important for them to be able to have high quality staging data. And it's something that they've struggled with for a really long time across all of their QA teams. And so we essentially use Tonic there to be able to, aggregate, create subsets, and then dynamically run these off of a continuous integration system. So they kick off jobs regularly when they want to import more data into staging, and it saves a significant amount of time, and also generally from all of the domain teams that work there has made their lives a lot better when it comes to testing and really not needing to worry about a lot of the security that they have for production. They're just free to use the staging data as is, and they don't have to worry about it, having anything sensitive in it. And this includes, their entire, 4,000 plus developers worldwide, and we're continuing to build this out at eBay to this day. Yeah. And you can also see various bits. I would say that, subsetting is probably one of Tonic's big, core aspects. Recently, we were in Fast Company for its list of most innovative small companies. And a huge part of this is our ability to subset, in addition to some of our data synthesis work as well, in case you want to grow the database. And I would say is a key differentiator compared to a lot of products that we've seen. Notably, one of the things that caused us to build this in the first place was our need to actually work with subsets. In addition to the fact that we had a really hard time finding other tools that actually did this in a way that was useful and easy for folks. Yeah. So what's next? We're definitely looking to make the feature better for our users. We want it to be faster. We want it to be, better suited for our customers' use cases. Just like all data sets, it can be highly contextual based on, whatever domain that data is in. And so really making sure that we can support a wide variety of interesting schemas or designs, and have a very flexible tool while also maintaining the amount of configuration necessary to get it work. We want this to also be pretty easy to use. And we're also looking to continue to expand our technology to even more of our supported data stores. And this definitely gets more interesting in the NoSQL world. But we've already done a ton of work in SQL already at this point. Happy to talk about specific databases. And yeah, that's pretty much it. If you have any interest in booking a demo, you want to look into this more or hear more context about how this could work for your use case, you could visit our website. There's a large book a demo now button. And then you can also email us as well. And yeah, that's pretty much it. Oh, one more thing. I wanted to show just a very brief demo of what this looks like in Tonic. So just for context, this is a very simple database that exists. And really all the subsetting comes down to is what we've explained already, where you say, hey, I would like 1% of the products tables. These are going to be the tables that are referenced ultimately in it. And what you can do is after running a data generation, what we can do is, so this, you can see we have some of the upstream and downstream tables actually going on here. You'll find that the output data set is a lot smaller. And so for example, if I'm looking at, let's see, products, for example, is a good example, where originally we had much more products that could exist here. And in fact, we have it where in the original data set, you can see that the original count of products was at 2,500, as well as the wholesale, which is a related table to products, had 7,000 rows. And if we are going to query the output, as a simple context there, let me see, actually run this statement again. It went down to 29 and 56 respectively. And Tonic is really good at actually letting people know if something went wrong or if the referential integrity wasn't able to be maintained for one reason or another. But in this case, it worked out just fine. So yeah, happy to show more of this in future demos, etc. Feel free to sign up for one.
Johnny, could you provide a little bit of context quickly for people who might not be so familiar with how Tonic is set up? You're showing us Tonic and then you jumped into your database. Can you just kind of explain where Tonic sits in the process?
Sure, absolutely. So the way that Tonic works is that you essentially provide a source database, which is often going to be the production database. In this case, I had this subset test kind of set up, and then you provided an output database where it's going to ultimately send the subset over to. And so the database view here is on the left, we have all of the tables that are present, as well as all of the columns. And this can make it very easy for configuring if I want to protect certain types of information. You can actually see here, for example, I've actually set up a bunch of generators. So you have customer's first name, last name, gender. These are all masked by default. Likewise, for products, like the product name has been changed. And what I went to was just looking at the view for it. And so this is what the original data looks like for products. So you can see there's Nike, Adidas, etc. But after the masking is performed, like these are all end up being scrambled. And so the table view allows you to basically have like a bit of a snippet of what the table looks like. And so this second tab that I actually have showcases the output of that database. And so this has no generators on it right now. And you can see this is what the output of the all the masked product names were originally from here. So even though they had all these names, Nike, Adidas, etc., and the subset that we came out with, it's also masked as well. And a low number of rows, so you get the best of both worlds.
That's great. Thank you. That's a fantastic presentation. We do have a bunch of questions, so I want to jump over to those. The first question was just a simple one, to talk a little bit about the databases that we support.
Yeah, certainly. So we, out of the box, we support most SQL-based databases. And so this includes Postgres, MySQL, SQL Server, Oracle. I believe we support it on DB2 now, and I might be missing another. I think we'll have Redshift very shortly, and this is an ongoing thing. We're continuously building this out, and we're also looking into supporting this with Mongo in the future as well.
Yeah, great. Then another question. How does our commercial subsetter differ from our open source subsetter? For those who might not know about it, we have an open source subsetter called Condenser. Share a bit about that.
Yeah, certainly. So the main differences between it is one, Condenser doesn't handle the scale that the Tonic does. It's useful for when you have a smaller database on the order of like a couple gigabytes, but it gets a little unwieldy in like how long it can take to actually generate the subset if you have a lot of data. The second thing is it doesn't include any masking. So the ability to get rid of all this private information, the open source tool just shrinks down the database. So you have to handle that yourself as well. In addition, it also doesn't reflect some of the latest innovations at Tonic with regard to the algorithms that it uses. And notably, this means that in certain cases, it doesn't actually, grab all the data that you might be expecting, especially with regard to optional data. Yeah.
That's probably a good segue into this other question. Someone says, I saw the announcement in your product news email yesterday about how your subsetter now uses a full algorithm approach. Could you explain what that means?
Yeah, sure. So this is actually one of the differences between Condenser and the subsetter in Tonic is that the original algorithm really tried to optimize on minimizing the amount of data grabbed, especially optional data, because we didn't want to grow the subset too much. But some of the characteristics of this algorithm meant that certain tables might end up being empty because it's optional data, right? And it's still valid. And so after working with a lot of our customers and really seeing some of these cases come up over and over again, we developed a new algorithm, which is called the full algorithm, which essentially means that that all connected tables for all the dependencies and whatnot, all of those tables will actually end up getting subset. Some of them may pull very little data, but what we found is that it has a lot more utility to make sure that there's a little bit of data everywhere that's actually necessary for the use case. It doesn't necessarily grab data from every table in the database, but but it does make sure that pretty much most cases that we've ran into of where people expect to see data, like there actually ends up being data in the subset.
As a follow-up to that, I think it'd be good to highlight like the way that Tonic allows you to, if you want to make sure that there is a table not in the subset, could you talk about, truncating tables so people know that you can still customize your subset to exclude things?
Yeah, certainly. So even in the product, there's a couple interesting things. So if we're looking at, like, for example, the database view here, by default, the table mode is masked, which means that it's going to, use our generators to be able to, remove a lot of the private information that exists. But you also have the ability to set these to, for example, truncated, tables. And what that means is that the table schema will be copied over, but none of the data will be present. So for this like customer's legacy table, that might be a good reason to go ahead and truncate it. Likewise, we also have some other options available. We have, for example, this include tables out of subset. And what this means is that if you decide to subset the products table, the customer's legacy table doesn't actually have a relationship between these two. And so by default, that table is going to be truncated. But let's say for whatever reason, you wanted that to just be copied over directly and you wanted to still include that data in the subset, you have the ability to just check this button here. Likewise, if you change this target to customer legacy, et cetera, this preview is updated to give you an idea of what tables are connected and will actually end up in the subset and which ones, will just end up getting truncated as well. So there's a lot of options in order to ensure that you're getting the subset that you want, especially if you include multiple targets.
Great, thank you. I've got one more question here. Someone asked, I would imagine foreign keys play an important role in subsetting using your approach. What if I don't have foreign key relationships set up in my database?
Yeah, this is a really good question. So by default, Tonic allows any user to augment the relationships that exist in the database. And it will both use the relationships in the database as well as anything else you tell to do it. And so, for example, what we have here actually is like a foreign key tool. This can actually be done manually by hand, but we find it's a lot easier to use the tool in the product. But the idea is that you can add additional relationships. So for example, you could find that there is a birth date column. And so this exists in 3 tables, the customer's legacy, customer's marketing, et cetera. You could decide that, these are all a foreign key to the employee birth date or something like that. And that would essentially allow you to add those relationships to the database as well. We've had some customers where they've had to add like a ton of them very quickly, and we find that matching by name honestly just saves a ton of time and is usually an easy way to go about it. And one of the benefits is that Tonic has a system for handling cycles. So even if you introduce a cycle this way, we still make sure that the subset is properly processed. Yeah.
Okay. All the open questions I have currently. Does anyone else have any questions? Comments? Anything at all? Okay. If not, I guess we'll wrap things up for today. Like we said, feel free to reach out to us if you have more questions. hello@tonic.ai. Hop on our website. You can book a demo. We've got the Amazon gift cards ready to go. And thank you for joining us.
Yeah, thanks so much, everyone.
Thank you, Johnny.
Yeah, thank you.